Question 1a. Define zeroth law of thermodynamics. Zeroth law of thermodynamics states that when two systems are each in thermal equilibrium with a third system, then the two systems are also in thermal equilibrium with one another. This law gives the basis for measurement of temperature. Question 1b. Define dryness fraction of steam. Dryness fraction of steam is the ratio of mass of actual dry steam to the mass of wet steam containing it. Its symbol is X. The formula is X equal to Ms divided by Ms plus Mw, where Ms is mass of dry steam and Mw is mass of water in suspension. Question 1c. What is universal gas constant? State its unit. Universal gas constant is the product of molecular mass and specific gas constant of any gas. It is constant for all gases. It is denoted by Ru. Ru is equal to M multiplied by R. Its unit is kilojoule per kilogram mole Kelvin or joule per mole Kelvin. Its value is 8.314 kilojoule per kilogram mole Kelvin. Question 1d. State Dalton's law of partial pressure. Dalton's law of partial pressure states that the total pressure exerted by a mixture of gases is equal to the sum of partial pressures exerted by individual gases, if each gas separately occupies the same volume at the same temperature. Therefore, P is equal to P1 plus P2 plus P3 up to Pn. Question 1e. Write basic functions of condenser. The basic functions of condenser are, first, to maintain very low back pressure so as to obtain maximum possible energy from steam. Second, to condense exhaust steam and reuse it as pure feed water for boiler. Third, to remove air and non-condensable gases. Question 1f. Define thermal conductivity and give its unit. Thermal conductivity is the amount of heat conducted through a body of unit area and unit thickness in unit time, when unit temperature difference is maintained between the two phases. According to Fourier law, Q is equal to minus Ka into dt by dx. Its unit is watt per meter Kelvin. Question 1g. Define mean effective pressure for IC engine. Mean effective pressure is the hypothetical constant pressure which, if acted on the piston during the working stroke, would produce the same net work as actually produced in one cycle. Mean effective pressure is equal to work done per cycle divided by stroke volume. Its unit is bar or Newton per square meter. Question 2a. Prove that COP of heat pump is equal to COP of refrigerator plus 1. For a refrigerator, heat absorbed from low temperature body is QL, work supplied is W, and heat rejected to high temperature body is QH. From energy balance, QH is equal to QL plus W, COP of refrigerator is QL by W. COP of heat pump is QH by W. Substituting QH equal to QL plus W. COP of heat pump is equal to QL by W plus 1. Therefore, COP of heat pump is equal to COP of refrigerator plus 1. Question to be: state Kelvin-Planck and Clausius statement of second law of thermodynamics. Kelvin-Planck statement says that it is impossible to construct a heat engine operating in a cycle whose sole effect is to convert heat energy from a single thermal reservoir completely into equivalent work. Clausius statement says that it is impossible for a self-acting machine working in a cycle to transfer heat from a body at lower temperature to a body at higher temperature without external work. Question to C. Represent isobaric process and isochoric process on PV and TS diagrams. The diagrams show both processes on PV and TS diagrams. In isobaric process, pressure remains constant, so P is equal to constant. In isochoric process, volume remains constant, so V is equal to constant. Question to D. A gas expands at constant pressure. Calculate the work done by the gas and increase in internal energy. Given volume V1 is 0.5 meter cube, V2 is 1.2 meter cube, pressure is 10 bar, and temperature T1 is 473 Kelvin. Cp is 1.005 and Cv is 0.712 kJ per kilogram Kelvin. Therefore R is 0.293. Mass is PV1 divided by RT1 equal to 3.608 kg. At constant pressure, T2 by T1 is equal to V2 by V1, so T2 is 1135.2 Kelvin. Work done is P into V2 minus V1 equal to 700 kJ. Increase in internal energy is mCV into T2 minus T1 equal to 1701 kJ. Question 3a. A vessel contains gas and heat is supplied at constant volume. Find the temperature of gas. Given volume is 0.03 meter cube, initial pressure is 350 kilonewton per square meter and initial temperature is 308 Kelvin. Using gas equation PV equal to mRT, mass is equal to PV divided by RT, which gives 0.1176 kg. Since volume remains constant, pressure divided by temperature remains constant. Therefore T2 is equal to P2 by P1 multiplied by T1. Substituting values, T2 is 924 Kelvin or 651 degrees Celsius. Question 3b. Explain construction and working of surface condenser with neat sketch. The figure shows a surface condenser. It consists of an airtight cylindrical shell with a large number of water tubes fixed between tube plates. Baffle plates guide the steam flow. In working, exhaust steam enters the shell and passes over the outside of tubes. Cooling water flows through the tubes. Steam gives heat to the cooling water and condenses. The condensate is removed by extraction pump. Question 3C. Explain construction and working of forced draught cooling tower with neat sketch. Forced draught cooling tower consists of a fan, spray nozzles, circulating pipe, water tank, eliminators and pump. Hot water is sprayed from top. Air is forced upward by a fan placed at the base. Air and water flow in opposite directions. Heat is rejected to air and cooled water is collected at the bottom. Question 3D. Give classification of boiler. Boilers are classified as follows. According to contents in tube, they are fire tube boiler and water tube boiler. According to circulation, they are natural circulation and forced circulation boilers. According to position of furnace, they are internally fired and externally fired boilers. According to axis of shell, they are horizontal, vertical and inclined boilers. According to pressure, they are low pressure and high pressure boilers. According to number of tubes, they are single tube and multitubular boilers. Question 4a. Define various modes of heat transfer with suitable example. The three modes of heat transfer are conduction, convection and radiation. Conduction is transfer of heat through a solid body or stationary molecules without actual movement of matter, for example heating of a metal rod. Convection is transfer of heat due to actual movement of fluid particles, for example heating of water. Radiation is transfer of heat without any medium by electromagnetic waves, for example heat received by Earth from the Sun. Question 4b. Determine the rate of heat flow through a composite boiler wall. Given thickness of steel is 0.02 meter, thickness of insulation is 0.005 meter, thermal conductivities are 58 and 0.116 watt per meter Kelvin, and temperature difference is 250 degrees Celsius. For composite wall, heat flow per square meter area is temperature difference divided by total thermal resistance. Substituting values, Q by A is equal to 250 divided by 0.02 by 58 plus 0.005 by 0.116. This gives 5754 watt per square meter. Therefore, the rate of heat flow is 5.754 kilowatt per square meter area. Question 4c. Differentiate two-stroke and four-stroke IC engine. The table gives the main differences between two-stroke and four-stroke IC engines. In two-stroke engine, the cycle is completed in 2 strokes of piston, while in four-stroke engine it is completed in 4 strokes. Two-stroke engine gives 1 power stroke in every revolution, while four-stroke engine gives 1 power stroke in 2 revolutions. Two-stroke engine uses ports for inlet and exhaust, while four-stroke engine uses valves. Power output is higher in two-stroke for the same size, but four-stroke has comparatively lower power output. Fuel consumption is higher in two-stroke and lower in four-stroke. Question 4D. Explain diesel cycle with PV and TS diagram. The PV and TS diagrams show the diesel cycle. The processes are: 1 to 2 is isentropic compression, 2 to 3 is constant pressure heat addition, 3 to 4 is isentropic expansion, and 4 to 1 is constant volume heat rejection. Question 4E. Determine whether the steam is wet or superheated and calculate the required value. Given pressure is 9 bar and specific volume is 0.30 meter cube per kilogram. From steam table at 9 bar, saturation temperature is 175.4 degrees Celsius and specific volume of dry saturated steam is 0.215 meter cube per kilogram. Since the given specific volume is greater than Vg, the steam is superheated. For superheated steam, V is equal to RT by P. Therefore, T is equal to PV by R. Substituting values, T is 585 Kelvin or 312 degrees Celsius. Hence, the steam is superheated and the superheated steam temperature is 312 degrees Celsius. Question 5A. Write steady flow energy equation and apply it to steam turbine and steam boiler. The steady flow energy equation per kilogram is Q plus H1 plus C1 square by 2 plus GZ1 is equal to W plus H2 plus C2 square by 2 plus GZ2. Here Q is heat supplied, W is work done, H is enthalpy, C is velocity and Z is elevation. For steam turbine, heat loss, potential energy change and kinetic energy change are usually neglected. Therefore, turbine work is H1 minus H2. For steam boiler, no shaft work is done and changes in kinetic and potential energy are neglected. Therefore, heat supplied is H2 minus H1 and for mass flow rate M, Q is equal to M into H2 minus H1. Question 5B. Derive characteristic gas equation using Boyle's law and Charles' law. Let 1 kilogram of ideal gas change from state 1 to state 2 through an intermediate state 2 dash. Process 1 to 2 dash is at constant pressure and process 2 dash to 2 is at constant temperature. By Charles' law, V1 by T1 is equal to V2 dash by T2 dash. Since T2 dash is equal to T2, V1 by T1 is equal to V2 dash by T2. By Boyle's law for process 2 dash to 2, P2V2 is equal to P2 dash V2 dash. Substituting this value, we get P1 V1 by T1 is equal to P2 V2 by T2, which is constant and equal to R. For mass m of gas, PV by T is equal to mR. Therefore, PV is equal to mRT, which is the characteristic gas equation. Question 5c. Explain Benson boiler with neat sketch. Benson boiler is a high-pressure, water tube, forced circulation, once through boiler. It has no steam drum. Feed water is pumped through economizer, radiant evaporator and superheater coil. At supercritical pressure, water is directly converted into steam without bubble formation. Superheated steam is supplied to the turbine. Its advantages are compact size, quick starting, high efficiency and suitability for large thermal power plants. Question 6a. Differentiate between impulse turbine and reaction turbine. The table shows differences between impulse turbine and reaction turbine. In impulse turbine, steam completely expands in nozzle and pressure remains constant during flow through blade passage. In reaction turbine, steam expands partly in nozzle and further expansion takes place in rotor blade passage. Relative velocity remains same in impulse turbine, while it increases in reaction turbine. Impulse turbine is used for high head and low flow rate. Reaction turbine is used for medium head and high flow rate. Impulse turbine has symmetrical blade profile, while reaction turbine has non-symmetrical blade profile. Question 6b. Classify heat exchangers and state their applications. Heat exchangers are classified according to nature of heat exchange as direct contact type and indirect contact type. According to construction, they are tubular, shell and tube, plate type and extended surface type. According to direction of fluid flow, they are parallel flow, counter flow and cross flow. According to pass arrangement, they are single pass and multi-pass. According to physical state, they are condensers and evaporators. Applications are automobile radiator, condenser of refrigerator, oil coolers, intercoolers, air preheater, economizer, superheater, milk chiller, and chemical and food industries. Question 6c. Define compression ratio, swept volume and cutoff ratio. Compression ratio is the ratio of total cylinder volume before compression to clearance volume. It is given by RC equal to Vs plus Vc divided by Vc. Swept volume is the volume swept by piston when it moves from top dead center to bottom dead center. It is given by Vs equal to pi by 4 into d square into L. Cutoff ratio in diesel engine is the ratio of cylinder volume at the end of fuel cutoff to the volume at the beginning of fuel injection. Cutoff ratio is V3 by V2.